So the second term is a plus d.
Well done.
And would the sixth term be a plus 5d?
Mm-hmm.
So that means if you put them together,
Yeah.
So we get 2a plus 6d makes 14.
Mm-hmm.
So if you simplify and divide it by 2, then we get what we wanted from the question, the a plus 3d equals 7.
Yeah. Equals 7. Any idea about B? They give you that formula, don't they? No. No. Forgot that first bit. Is it?
So the sum of the first 20 terms is equal to 20 over 2 bracket 2a, because we don't know what a is yet, plus brackets 20 minus 1, which is 19, times d, which we don't know yet. So that is 10 outside, so 10 times 2a is 20a plus 190d. Equals minus 120.
Yep.
And then do we do simultaneous equations?
Love it. And how would you do that?
With the a plus 3d equals 7. So do you like rearrange it so a equals 7 minus 3d?
Both linear. I think we can get away with calculator.
Okay.
I'll need to check though. It allows us to just do that. Do you know how to do it?
On my calculator, I got x equals 13 and y equals minus 2. So that is a, and yeah.
13 and minus 2. Yeah, you don't have to actually do the whole substitution thing. They're both linear. And so no extra marks for doing it manually. Grand, I think you're good. Yep, you got the idea there. Let's see. The fifth term of an arithmetic sequence, the 10th term is this. All right.
So I'm not too sure how to start.
Just like the last one. Make an expression for the fifth term, or an equation for the fifth term in this case.
How did we start it last time?
Yeah, gee, the man. We said the second term is a plus d. The sixth term is a plus 5d.
So here, the fifth term would be a plus 4d.
Yep.
Is equal to 33.
Yep.
And then the 10th term is a plus 9d equals 68.
Mm-hmm.
I'm not sure what to do with the 2,225.
Do nothing.
Do we do simultaneous equations with those there?
Sure do.
So do we just type it in the calculator?
Sure do. If you can stop cheeking this man for 5 seconds.
I got a equals 5 and d is 7.
Right. Sum to n terms is this. Now how do we use that?
S of n.
Yep.
Is equal to n over 2. And then brackets 2n.
2a plus n minus 1 d. So that's s, sum to n terms.
Okay, so that equals the 2,225, and we can sub in the value of a and d. So 2 times 5 and 7. So that's like 10 plus 7n minus 7.
So n over 2, 10 plus 7n minus 7.
So if we times everything by 2, then that gets rid of the 2 on the left hand side, and we need to times the right hand side, so that will become 4,450. Then we expand the bracket again, so 10n plus 7n squared minus 7n equals 4,450. So if we simplify that, then we get the 7n squared plus 3n minus 4,450 is equal to 0, which is what we want.
That's it. That was plus 3n, and then you bring it over. Yeah, so we had to do simultaneous equations to find a and d, and then we sub a and d and 225 into the formula, and B.
So just sub that into the calculator. N equals 25 or minus 25 has to be 25.
Yeah, because it's the number of terms in a sequence. Yeah, you see, to get the marks, I think you have to sub into quadratic formula. So just watch out for that. So just sub into just sub into quadratic formula, and then you can write stuff down. Let me see this one. Alright, you're gonna make me do this one.
So A plus 14D is 11, and A plus 19D is 37 over 2. Simultaneous equations?
Yes. You want an invitation for the simultaneous, I bet.
A equals minus 10 and D is 1.5.
Okay. A is minus 10, so that's the first term. Right, what's the second term?
A plus D, so minus 10 plus 1.5. So minus 8.5.
That's good to me. Do you think you'd be okay for part B?
You do that by using the formula.
Which formula? Oh wait, yes.
The one that's like S of n and then equals
correct.
n over 2.
Yeah, correct. So you'd sub A and D into that formula, make it equal to that, and then solve it. Solve it the old-fashioned way. Let's see. I need to get 60. So I think you're gonna be fine for that. You know, that aspect of it. Oh, all right. Shaking me. Any idea about this one?
I'm not sure how to start.
It's a thinker. What is A?
K plus 1.
What is D?
K plus 2.
Yeah. So that's A, that's D. Let's see. This is... so some term in here is A plus n minus 1D gives you 303. Right. I don't know. Sub in A and D maybe? What would you get?
So K plus 1 plus brackets n minus 1 times K plus 2 is equal to 303. So if we simplify that...
Hold on. How much are you simplifying? I suppose you could subtract 1 from both sides. That's about as much simplifying. So I don't really have an idea for this one yet. I don't want to have Kn. That's what I want.
Oh yeah, true.
Let's see. So we still got 2 unknowns. I mean, whatever. Let's see.
302.
Find the number of terms in the series. So they actually have this thing in terms of K, even in part of B. Let's see. So what equations do we know? We know A, first term, A plus D. Yeah. So I know a formula, but it might be cheating. Involving first plus last. What we could do, you know how like A plus n minus 1D? Do that with U1. What do you get?
What? A.
So A plus n minus 1D is the nth term.
Yeah.
So first term.
K plus 1 plus 0D. So just K plus 1.
Yeah. I don't like where this is going. Okay, U2. Yeah, because they're not really equal to anything, are they? That would be K plus 1. So literally, they're just identities. Is it first and last thing? Is that what I should be doing? Wait, what? They did it. Oh, I'm a moron. In terms of K. Yeah. So we can't solve it. You just make it n equals. Sorry. Yeah. So yeah, make n the subject basically. So what would that be?
You have to divide by. So.
Oh no, expand the brackets now. Well, whatever you want. Whatever you want.
Okay, so if we expand the brackets, we get Kn minus K plus minus 2 plus 2n. So that simplifies out to kn plus 2n minus 2 equals 302.
Kn plus 2n. Yep. Even simpler.
So divide by n now.
Add 2.
Wait, what would you mean?
Add 2 to both sides.
Oh, kn plus 2n equals 304.
Yeah, then divide by n, what do you get? No. We want to make n the subject.
So divide by k?
Factorize n.
K plus 2.
Yeah. Now make n the subject.
N equals 304 over k plus 2.
That's it. Okay. How would we do b?
So S of n equals n over 2 brackets 2 brackets k plus 1 close brackets plus n minus 1 times k plus 2.
Yep. And do you know what you do next?
Expand it.
Spot the difference between their one and our one.
Divided by k over 2 plus 2.
The biggest difference is we have an n, they don't.
Oh. So
how do we eliminate
how do we get?
It's because in part A, what did we say n was the same as?
(304 over k plus 2).
And how can we use that? We're trying to eliminate n.
Oh, sub that in for n.
Correct. Wherever there's an n, replace it with 304 over k plus 2, and then you do lots of expanding, and you hope that you have that at the end. And what I would do is I would just sub it in and just write the answer.
Yeah.
Let's see how wrong I am. So yeah, wherever there was an n, they replaced it with 304 over k plus 2. So instead of n over 2, it's 304 over k plus 2 over 2. They have cheated. They snaked me. And they mostly just went straight to the answer after that. Yeah, they did the first plus last thing. A very simplified version of the formula, which I'm sure I'll regret showing you, is n over 2 first plus last. If you know, last term is the same as n minus 1d. No, a plus n minus 1d. And that ends up being 2a plus n minus 1d because you already have an a. How would you do part C?
So the equation from part B is equal to 2,568.
Yeah, and then you just solve it. You think you're okay for that?
Yeah, I think so.
Yeah, grand. Let's see. Yeah, so this was weird because it was all in terms of k. Man, I want to not do this stuff. Second, third, and fourth term. Is that, and that? Alright. Fine. How do we do it?
So the second term is u2 is equal to a plus d. So a plus d is equal to 3k. And then a plus 2d is equal to 4k plus 5. So you can do, I don't know.
There was something that wasn't available in the previous one because it was identical that I think will be available in this one. I think so. These two, what is D?
K plus 5.
These two, what is D?
I don't know.
Second term take away first term. Term 3 take away term 2.
I don't know what to do with the plus 5.
I don't know what to do with you. 7k take away k plus 5. Taking away a bracket is the same as expanding it by -1.
Minus 4k minus 5.
So it's 7k minus 4k minus 5. Simplify.
$3k minus 5.
D is 3k minus 5. In the first one we said D is 1k plus 5. What do you do next?
Simultaneous.
Yes. K is a number to be found. So D is second term takeaway first. D is also third term takeaway second. It's any term takeaway previous. any term plus d gives you next term. D is any term minus previous. And then you have to calculator it up. It'll be easier if you put the two unknowns on the same side of the equal sign.
Wait, what?
The calculator, the format that the calculator takes it in is with the two unknowns on the same side.
Oh, so we need the numbers on the other side. So 3k minus d equals 5.
Yeah, or you can just move the other one over.
Yeah. And d minus k equals 5. So 1. I got x equals 10 and y equals 5. So d equals 10 and k is 5.
That's it. K is 5. And so we have to show that the first n terms of the sequence is this. How do we do that? So S of n equals n over 2. Wait, no. Let's see. So we have D, we have K. Any ideas?
I'm not sure.
Find A.
So D is k plus 5. So 2k plus 5. No,
Go back up to the
minus 5.
Original equations.
Wait, what original ones?
U2.
Yeah, U2 equals A plus D equals 3k.
Uh-huh.
Oh, if we sub in, so A plus 10 equals 15, so A equals 5.
A is 5. D is 10. K is 5. We want sum to n terms of this sequence.
Now we do, S of n is equal to n over 2 brackets 2 times 5, which is 10, plus n minus 1 times 10 is equal to kn squared.
To show that, so let's not say it's equal to kn squared. Let's just simplify it.
So 5n
Yep.
And that bit inside the brackets would be plus 10n minus 10. So if you do 10n times n over 2, 5n minus 5.
I believe it is 5n squared. So 10n times n over 2.
Okay, yeah.
Alright. And then you had n over 2 times minus 10.
Minus 5n.
Simplify.
N squared.
N squared. What is k?
5.
We said k was 5. This is 5n squared. They wanted kn squared. Therefore k equals 5. Boom. There you go. Don't overthink it. Let's see. This uses a very common trick. Next term minus previous term. Do that twice and then make them equal, and then solve, basically. And then just go from there. I don't want to do this anymore. Okay, let's see this one. Calculate the sum of this. In the arithmetic series, where p is a positive, find in terms of p an expression with a number of terms. Don't want to do it anymore. Let's see this one. Right. This one seems nearly identical. Yeah, gee, the man. Put that there. Right. How do we start this one?
So U3 equals A plus 2D, which is equal to 3K. And U4
Doesn't matter.
Oh.
You could. That's long, man. Anything else you could do?
I'm not sure.
I will literally. How do you find D?
Oh, the difference. So 4K plus 3 minus 3K is K plus 3.
Yeah. So that's D. What else is D?
6K minus 9 minus 4K plus 3. So 2K minus 6.
Calculator?
Minus minus 12.
Mm-hmm. Equals?
D.
Mm-hmm.
So
you're trying to put me in an early grave.
Sorry. 2.
You should be sorry putting me through this.
So, D minus K equals 3. No, wait.
Yep.
Yeah. And then for the other one, D, so 1 minus 2K is equal to minus 12. And I got that D equals 18 and K is 15.
Okay.
Now do we use that in the equation for the sum?
Yep. You don't know. You don't know what A is though.
Oh yeah. How did we work out A last time?
You have U3 over there.
A plus 2D equals K. So, oh yeah. So A plus 2 times 18 equals 15. So 2 times 18 is 36. So A plus 36 equals 15. So 15 minus 36 gives A equals minus 21.
So now what do you sub into the...
Now we have S of n equals n over 2 times 2 brackets minus 21 plus n minus 1 times 18 is equal to a square number. So then we expand that. So n over 2 brackets minus 42 plus 18n minus 18
It'd be easier if you simplify the bracket first.
Minus 60 plus 18n. So minus 30n plus 9n squared.
So 9n squared minus 30. And we have to show that it's a square number. It seems wrong. Something seems wrong. If it's a square number, let's see. I thought of an easier way because we have the calculator. So you know how U3 is a plus 2d equals 3k, a plus 3d equals 4k plus 3, and a plus 4d equals 6k minus 9. So we could write it as a plus 2d minus 3k equals 0, a plus 3d minus 4k equals 3, a plus 4d minus 6k equals minus 9. I always forget. So you can simultaneous equations more than just two. You can do 3. Oh, can you hear me?
Yeah.
Can you hear me?
Yeah.
Can you hear me?
Yeah. Can you hear me?
Okay. Can you hear me?
Yeah.
Sorry, no idea what happened.
Yeah.
Then we can just calculate those three. 1, 2, minus 3, 1, 3, minus. No, I have to make it equal to something, don't I? What did I do? Menu. Simultaneous equations, 3 unknowns. So I need 1, 2, minus 3, and 0. Yeah. 1, 3, minus 4, and 3. 1, 4, minus 6, and minus 9. So we get A is 9. D is 18, and that is 15. So I'm getting plus 9. 9.
Yeah.
Equals 9. 18 and 15. So this should be a plus 9. Who knows why? We missed a minus somewhere. So we sub in A shouldn't be minus 21, it should be 9. So that would be 18. Aha, what happens there?
N.
N over 2 times 18n. N times n?
9n squared.
Yeah, 9n squared. What squared gives you 9n squared?
3.
That gives you 9. We want 9n squared?
3n.
Yes. That is equal to 3n squared. Therefore, it's a square number. It's 3 times, whatever n is squared. So it's always going to be a square number. We just went wrong somewhere with a minus sign, I think. We got A is minus 21. It should have been positive 9. The easiest way is 3 simultaneous equations. is a square number. Yeah, 3n squared. So you have to put it in the form of something squared. Let's see, how did they do it? They did it the D way, and then, yeah, I think just 3 simultaneous equations. All right, 3 simultaneous equations, and then you sub it into the sum formula. Why is there more? I wanted to just do geometric, because it's actually lots of fun. All right. Do we recap or do another? You pick.
I don't mind.
Right. I have to punish you then. Let's see. Let's do question C.
Okay, so you
hang on. Let's do better than this one. Find P, A, and D.
So U1 is 3p plus 2. So is that A?
Mm-hmm.
And then D is 2p plus 1.
What is U2?
5p plus 3.
And in terms of A and D?
A plus D.
And U3?
7p plus 4, which is A plus 2D.
They might have thwarted us. It might be an identity. I think U2 and U3. Yeah, they might have thwarted us, did they? That's going up by 1 each time. It's going up by 2p. Alright, so... Alright, using this then, what is D? I was going to say we could do simultaneous equations, but I think they snaked us. Oh, you cheated, man. Right, how do you do part A?
Do you have to use the sum formula?
Yeah. Do you remember the easier version of it?
I know.
N over 2 first plus last. Oh, but we don't know N, do we? Oh, well, what do you think? What is N?
$99.
Definitely not.
Oh.
Let's see. All right. What is A? What is D?
A is 3 and D is 3.
D is 3. And we need N. Let's see. If it's going up in 3s each time, starts from 3, reaches 99. How many terms in total?
96.
I think it's 33.
Wait, no. Yeah.
33 or something. Yep. N is 33. Because D is 3. Yeah, 99 over 3. And so sum of that.
The sum of 33.
The sum of this sequence.
Oh. So okay. 33 over 2 brackets 3 plus. Wait, what is that again?
Last term.
99.
Yep. And that is a quick way to tell you what you get if you do 3 plus 6 plus 9 plus 12 plus ... all the way up to plus 99.
Okay, I got 1,683.
1,683. I'll take it. So this stuff, a lot of it is creating formulas, creating equations and using them to solve stuff using that a plus n minus 1d and the other formula. Make an equation, solve it, basically. And so that stuff, what do you give yourself?
A half.
That's just because I'm so hard on you. Yes. How was that for you, Keelan?
Good.
Any topic in particular you want to do next time? We can do geometric, which is next. That's when you times by the same thing over and over. It's got its own formulae.
Probably that. Yeah.
All right. If not, you can let me know. Any questions from me in general?
No.
All right. Well done, Keelan. You did great. I look forward to talking to you again next week.
Have a good week.
You too. Take care.
Thank you.